So in this example, I'm going to do the exact same case. I'm basically just going to rewrite these. You guys don't have to do this, but again, I believe it's helpful, especially when you guys are oh, I marked in the wrong one. I already did this problem, but that's OK. Oh, no, I didn't. Jeez, oh, man. All right. So let's go ahead and go through this problem. So again, in this example, we know our slope is equal to 2 over 1. And our y-intercept is 0, negative 10. Over here, we have to solve for x. So you can see my y, to put in I'm sorry, we need to solve for y. To put it in slope-intercept form, we need to isolate the y. So I'll subtract an x on both sides. Then I have negative 4y is equal to negative x plus 5. Now, to isolate the y, I need to divide by negative 4. So therefore, I have y is equal to. Now remember, the 4 divides into both of those terms. And a lot of students forget that there is a 1 in front of that x. So to write this in slope-intercept form, this would be a positive 1/4 x minus 5/4. Anybody have any questions on how I did that? Yes? You're saying solving by substitution? We're going to do that today. I'm just focused on you guys practicing graphing right now. So when doing it that way, you can say that the slope is 1/4, and the y-intercept is a 0, negative 5 over 4. Interesting. So now our y-intercept's not an integer. So what do we do when we have our y-intercept that is not an integer? Well, we first start with the problem that's the easiest to graph, which would be this one. You go down to 0, negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we follow our slope, which is up 2 over 1. And again, guys, as I mentioned, when we're doing this, the more points that you can follow, so you go from your y-intercept, go up 2 over 1, up 2 over 1, up 2 over 1. Just keep on following your slope as best possible. And my graph, my spacing is really, really bad. OK? Now we go to the next one. The next problem, the y-intercept is at negative 5/4, which is just past between negative 1 and negative 2. Then that's telling us to go up 1 over 4. 1, 2, 3, 4. So even though my graph, I'll show you guys what to do, how to do this graphing to find the exact point. But if I was going to go ahead and estimate this, all right, I would estimate my coordinate point would be at 1, 2, 3, 4, comma, negative 1. All right. Now, again, I am just estimating with my graph. I will show you guys how to do that in a graphing calculator as well, so you can get the exact solution with that. OK? Since this is a common point, this would be a consistent and consistent independent solution. All right. Now, estimating is important when you